In this video, we're going to talk about scientific notation. What you see on the screen for this introduction is nothing more than a chart that might help you understand how scientific notation works and exactly what these exponents mean. Since we're talking about exponents, let's just talk about the components of scientific notation. You have a coefficient, that's your number before the times or multiplication sign. You have your base, which is going to be raised to the power of 10, and you have your exponent, and that exponent is a superscript, and we're going to get into that in a little bit. So we have some examples. Let's just talk about the first one, the speed of light. Now, the speed of light is 299 million meters per second. Okay, and so I want to put that into scientific notation. The first thing I'm going to do is move a decimal point. Now, I know that that decimal point is not there. That has to do with significant figures. If you're struggling with that, there is a video in your video library that will get you there. Okay, so you have your speed of light. We're going to put it into scientific notation. We'll move that decimal point. How many spaces? Well, that decimal point has to land in the coefficient space. Your coefficient is only going to be between the numbers of 1 and 9. So in order to get us to a number of 1 and 9, we're going to move that decimal that we cannot see. Okay, we're going to move that decimal 8 spaces. So we have 1, 2, 3, 4, 5, 6, 7, 8. That means my decimal is going to end up right in between that 2 and 9, and that puts my coefficient being between the numbers of 1 and 9. It will never be less than 1 or more than 9, okay, or more than, let's just say more than 10, because it could be more than 9 point something, but it won't ever be 10. Okay, so what that gives me when I move that decimal point is 2.990000 meters per second. Now, to put that in scientific notation, I moved it 8 times, and that's what I'm going to use that coefficient to tell me. So I round down 2.99 times 10 to the 8th. I don't need all those zeros. They are not significant. The reason they aren't significant is because there's no decimal after that last zero. Again, if you're confused on sig figs and the rules of zero, there are a couple of videos that could be very helpful for you in your video library. You can ask your instructor if you don't see them available to you. So our final answer is 2.99 times 10 to the 8 meters per second. And again, I got that exponent, that 8, because I moved that decimal point 8 spaces. All right, so just a couple of little rules to remember. If you move the decimal to the right, you're going to have a negative exponent or a small number. So 0.04387. If I take and I move that decimal to my right, okay, we're going to move it 2 places. That means it's 4.387 times 10 to the negative 2. So I move the decimal to the right, my exponent is negative, and I have a small number as my answer over here, okay? So I want you just to remember that that coefficient will only be between 1 and 9 point something. It'll never be 10, but that negative 2 has reminded me that I moved that decimal point 2 places to the right, and it works in the other direction also. So if we move the decimal to the left, we're going to get a positive exponent or a larger number. So we're starting with 438.7. Let's put that into scientific notation, and we're going to move that decimal point over 2 spaces to the left. That gives us the exact same number, 4.387. However, our exponent is a little bit different. It is a positive 2. Now we move that decimal to the left, which means we have a positive exponent, and our final answer, which is on the left of that equal sign, is a larger number. All right, so if we think about it the other way around, sometimes it can be a little difficult to wrap our head around when we're starting to think about things backwards, but that's what we're going to do here. We're going to move the decimal to the left and get a negative exponent or a small number. That means we're starting in scientific notation, okay? If we're starting in scientific notation, that exponent right there tells me to move that decimal 2 places. Now, I see that there's no number there. Now, I have to have a placeholder. And the way that I'm going to do that is I'm going to add a 0 there. So I move my decimal 2 places to the left. That means I have a negative exponent. And my number, my final answer is 0.04387. And that 0 right there, again, is your placeholder. You have to have something before that decimal. All right, so it works the exact same way again. We're going to move the decimal to the right with a positive exponent and a large number. So again, we're starting in scientific notation. This is the exact same problem. However, our exponent is positive and not negative. So let's move that decimal right over to the right. And because the exponent told us to move it 2 spaces, our final answer is 438.7. All right, so example 2. Here we have a rather small number, 0.0069005. We're going to move this decimal place 1, 2, 3 places, and that means we are now in scientific notation. Our number, our coefficient, is falling between the numbers of 1 and 10, right? So it's 6.90005 times 10 to the negative 3. And I know that negative 3 because I moved the decimal to the right. I had a negative exponent. I started with a small number, and that's how I got that answer. So example 3, we're going to do another one, 0.00500. We're going to move this decimal point how many places? 3 places over to the right. And we know that because our coefficient, again, has to fall between 1 and 10. So our answer in scientific notation is 5.00 times 10 to the negative 3. We move the decimal to the right, and we have a negative exponent, which means our answer is a small number. We're going to do it kind of backwards now, or how I think about it forward. We're starting in scientific notation. 6.302 times 10 to the second. Notice that's a positive exponent. And what did I tell you guys about the positive exponent? We're going to move that positive exponent over to the right 2 places. Okay, our final answer, 630.2. We move the decimal to the right. We have a positive exponent, so we end with a large number. And you got it. We're going to do one more. 5.1640 times 10 to the second. That means we're moving that decimal 2 places over to the right, and our final answer is 516.40. Again, we move that decimal to the right 2 spaces because that exponent is a positive 2, and that means our final answer is going to be a large number. All right, so if you have questions about scientific notation, how to take numbers into or out of, maybe you should reach out to your instructor or the tutorial center. There are lots of videos in the video library that could help you with scientific notation. I hope this video has helped you.